So you can all see my screen. It is about opening up a restaurant in Brickell. Let's check if this is a good idea or not, and see if we start a restaurant in Brickell sometime in the near future, right? So this is a hypothetical restaurant, but the initial investment is almost $1 million. It's 923,734, and the expected cash flows over the next 4 years are the following. So now this is asking about the discounted payback. So this is one of the tools of capital budgeting. And what I will do is first, I will get the regular payback period, and then I will get the discounted payback period, okay? So now these are the cash flows of the project, and this is what's happening. When you are looking or evaluating the payback period, you're mostly concerned about one thing: how fast am I going to get my initial investment back? So that is your main criteria to choose a project, to accept a project, to reject a project. If a project has a smaller, a faster payback period than another, then that's the one you would choose, right? So that's the criteria of this tool to make for financial decision making in capital budgeting. So let's follow a couple of steps. So we have the cash flows here, and then let's say here cumulative cash flows. And one additional thing, let's also include, and by the way, let's convert this text to columns, delimited, and just one by other that we're going to say by this. Okay, there we go. There we go. So now we separated. I just separated this into columns. That's the only thing I did, and these are the cash flows. So we basically we haven't done anything. So we are going to add one cash flow that we are missing, which is the initial outflow, which is the initial investment, and that one is 923,734. So, and that's going to be negative. So regular payback period is the following. Regular payback period. So what we do is this. First, we create this column that we call cumulative cash flows. In year zero, we a cumulative cash flow, the aggregate cash flow, the total cash flow we have invested so far. When we combine the inflows and the outflows, we have a net investment right here, a net outflow, cash outflow of 923,000. When we reach the end of the first year, then we have invested 923,000, but we have recovered 473,000. So our net cash flow is actually a net cash outflow of $450,000. Why? Because, well, we invested 923, but we got back 473, but we're still short by $450,000. Okay, we continue in the business, and then by the second year, then we add. So this is mere intuition. I mean, this is very simple. This is one of the simplest methods. We just add these two things, and when we add the two of them, well, we are still short. We have not recovered our initial investment yet by the end of the second year. So we should be aware that if we go forward with this project in Brickell, it will take us more than 2 years to recover our initial investment. Now, I will ask this: is it taking 3 years? Just by looking at this, is it taking 3 full years to recover my initial investment? Awesome, Daniel. And so, Daniel, a ballpark figure, like it is taking how long, basically? Yeah, awesome. Excellent. excellent. 2 years and 1 month, 2 years, and Shuhei gave us the calculation 35,000 negative divided by 404. So, long story short, if these are the cash flows, and I'm gonna paint this in black and then or in gray and with this border, these are the cash flows and third 3 year cash flows, third year cash flow, and the cash flow is 404,397, right? So then the moment we have this, we know that, well, it is not taking the entire third year. So at some point after we start the third year, we will have recovered the entire initial investment. And as Daniel was pointing out, well, that's basically 1 month. Shuhei is giving us the accurate calculation. And this calculation that Shuhei is giving us, let's just do this. So let's calculate the payback period. So it is going to take 1 year. Yeah, the first year completely. Yes. It is going to take another year. The second year. Yeah, the entire second year. But now it is only going to take. So if we want to know how much of this 404,397 this cash flow is, well, we are going to find out that it is about some percentage cash flow still needed, right, to recover our initial investment. So this yellow part of the entire third year, we can get it in the following way. Just dividing this, which is the amount of money that is left, so we can recover the full initial investment. And then we state it as a percentage of the entire third year cash flow. So we divide it by here. It will look negative because 35,000 is negative. So I will just add this negative sign, but that's a matter of choice. You can keep the negative sign if you want. And there we go. So basically you have 0.09, or in other words, a 9% of the year. So then it is going to be, now if you're going to add these three cells like I am doing, then you do need to change this sign the way I did it here, because then I can just add, and then I know that it's going to take 2.09 years to recover the initial investment. Okay, now there is one problem, and I'm going to copy this. Let me write here two-step DDM, and then in sheet 2, let's say payback period, which is, and then let me copy this, which is not the same as it's payback time. No, it's payback period. And now we have discounted payback period. And why is discounted payback period important? I'm going to show this right now. So now, let me open this. If we have an initial investment, this is time 0, 1, 2, 3, 4. I'm going to go 5, 6, 7, 8, 9, 10. And then we invest in period 0, $1 million. And then it takes us, so we get nothing, 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 nothing. And then in year 9, we are getting $950,000. And then in year 10, we're getting $50,000. Now, this project will have a regular payback period of 10 years. In turn, if we have another project which looks like this, we invest $1 million too, but then the very first year, we get 950, and then it's 0, 0, 0, 0, and then in year 10, we get the remaining $50,000. The payback period is 10 years. Now, I'm going to ask just quickly, you can type it or say it, unmute yourself and say it. Which of these two projects would you choose? Right, Daniel, project A is better, and the reason is project of, I'm sorry, B is better, and the reason, yes, excellent. Why? And the reason is you're getting almost all of the cash flows in 1 year. So the payback period, in reality, the payback period should have been like 1 year. But there is just a little remainder there, like a little remaining portion of your initial investment that you are going to get 10 years from now. But that is so small that it, it is very unfair to say that if you're evaluating or comparing these two projects using the payback period just as is, this is 10 years, and then this is 10 years, and this is 10 years. So both are the same, right? Exactly. So that is a great point, Daniel. Theoretical is the same payback period, but this is not being accurate in this case, right? And the model is the problem. So that's why we need discounted payback period, because then discounted payback period, we will discount these $950,000 and we will discount it to present value. So this will be a much lower figure, a much lower value, because we will basically apply intuitively, we will apply a big penalty to the 950,000 that we are getting in 9 years from now. So it will not, those will not represent $950,000 to us. It will represent a much lower value because it's happening so late in time. So this is the second approach. So now we are going to look at the discounted payback period, which, by the way, it was the original point asked in this question. And now it's telling us, it's the information, the question is giving us this discount rate, which is 6%. So the cool thing about this is what we will do is we will simply, you can simply repeat your regular calculation. So I'm going to copy this calculation here. And then I'm going to type here discounted. And here, what we will do is we will follow the same method, but before we solve the problem, we're going to take step 0. So the very first step, and the very first step will be, we're going to discount these cash flows. So we're going to copy this. We're going to do it exactly in the same way we did it before, exactly in the same way we solved the problem here. Just that before we start our calculations, we will type the cash flows here in present value and not in just the regular, the nominal values that we are expecting in the future. So we will do this. We can start with the initial investment, and then we divide that by 1 plus this, and let me type this rate in a cell of its own, 6%, like this. So we will discount this first one divided by 1 plus the rate to the power of time, right? I'm giving a couple of seconds so you can see the formula there. B7 divided by 1 plus B3 to the power of A16, where we have the time. And then we need to lock the rate because I'm going to scroll down. So F4, or you add manually those dollar symbols. Okay, now you can scroll down, and then all of what we are seeing here is that each one of these values are the present values of each one of these values. If we look at the last one, for example, what we see here is that this is B11, and we're dividing by 1 plus B3, so that's 1 plus the discount rate to the power of 4, to the power of time. Once we type discounted cash flows instead of regular cash flows, now we do the exact same steps we did before, and that's it. So cumulative cash flow in year zero, and one important thing you will notice that in year zero, the initial investment, even if now we are using the discounted values, the discounted value in year zero is the same because given that that initial investment is happening today in year zero, then discounted value discounting it's irrelevant. It doesn't make any difference. So cumulative cash flow in year zero is just our initial investment. And then we follow the exact same procedure we did before. When we reach the end of the first year, well, we acknowledge that we invested 923,000. That's an outflow. But now we're getting back 446,000. That's the discounted cash flow. So we still need $477,000 to recover the present value of we need $477,000 in present value to recover our initial investment. When we get to the end of a second year, then we acknowledge that we are still short by $477,000. When we add the $369,000, well, we are still short. And so by the end of a second year, we can see that we are falling short by much more than what we were falling short before. And then when we get to but now this is what we asked before, we do not need the entire third year to recover our initial investment. We only need a little part of this third year. And the way to get it is exactly the same way we got it before. So first, let's use these numbers here. It took us 1 year, entire year, yes. It took us the entire second year, yeah. And then the third year, we're just going to divide how much money we still need to recover our initial investment, and we're going to state that as a percentage of the third year cash flow. And just because this number is negative, I'm going to add this negative sign here, so the whole figure doesn't come up as negative, but rather positive. So we need almost 30% of that third year. Now, by the way, here we had the non-discounted cash flow, but now the discounted cash flow of the third year, it's no longer 404,000, but it is 339,540, right? So if we now add these up, it takes us, in terms of present value, 2.32 years. And if we had a problem like this one that we saw before, then the payback period of project B would be much lower than the payback, much faster than the payback period of project A, because these cash flows here would be highly discounted because they're happening so late in time. But okay, focusing on this, we just solve the discounted payback period in the same way we solve the payback period. But before we do anything, we convert these values here. We convert all of them to their present value. And once we have converted them to the present value, then we repeat the same steps and we solve it.